So exercise 10.2, we go for question number 15. Exercise 10.2, we can go for question number 15. What does the question say here?
Find the position vector.
Yeah. Find the position vector of a point R
which divides the line
which divides the line joining
two
two
points.
points P and Q whose position vectors are given. No? Okay. Yeah. So this is your three-dimensional coordinate system, the x-axis, the y-axis, the z-axis. There is a line joining 2 points A and B, or P and Q. A and B, P and Q. So there is a line joining 2 points P and Q whose position vectors are given. What is the position vector of P? Position vector of P shall be denoted by what? Vector A. Right? And position vector of Q, we can denote it by vector B. Okay, but you need to mention, okay? Let the position vector of P be vector A, no? Which is equal to, it's given, position vector of P denoted by vector A. I cap
Plus
2j cap
minus
minus k cap. And the position vector of Q denoted by vector B is equal to
minus I cap
minus I cap
plus j cap
plus j cap
plus k cap.
plus k cap. Now, what else? You want to find out? You want to find out the position vector of another point R such that this, in Roman 1, such that this R divides PQ internally in the ratio 2:1. So here we need to find out the position vector of R. Let the position vector of this point R be denoted by vector R. So let vector R be the position vector of point R. In question number 15, the first part, Roman 1, question says that R divides PQ internally in the ratio 2:1. Therefore, by section formula, position vector of that point R will be given by what? M times vector B plus N times vector A upon M plus N. Here your ratio is 2:1. That means M is to N is equal to 2:1, right? Ratio is 2:1. Therefore, your R, vector R, position vector of R, vector R will be given by M times vector B. So 2 times, what is your vector B? Minus I cap plus j cap plus k cap plus N times vector A. N is 1. What is your vector A? I plus 2j cap minus k cap upon M plus N, 2 plus 1. So here is minus 2i cap plus 2j cap plus 2k cap plus I cap plus 2j cap minus k cap upon 3. We are going to add the x components, y components and z components separately. Minus 2 plus 1 minus 1 I cap. 2j cap plus 2j cap, 4j cap, 2k cap minus k cap plus k cap upon 3, which is equal to minus 1 upon 3 I cap, 4 upon 3 j cap plus 1 upon 3. So this is the position vector of your point R. Is it okay? That means the coordinate of R will be given by, if you ask, what is the coordinate of R then? Minus 1 by 3, 4 by 3, 1 by 3. Is it alright? Similarly, you can go for the second one, okay? I think that's the last question. Or do we have more? Okay. So let us proceed with the next question. What is the next question?
And the position vector of the midpoint of the vector.
Okay.
Joining the 2 points P.
Okay. We need to find out the position vector of the midpoint of the line joining 2 points. See, in section formula, suppose there is a line joining 2 points A, x1, y1, z1 and B, x2, y2, z2. Let's say R is the midpoint of AB. R is the midpoint of AB means R divides AB into 2 equal parts. No ratio is required. In that case, the coordinate of R will be given by x1 plus x2 upon 2, y1 plus y2 upon 2, z1 plus z2 upon, okay, or z1 plus z2 upon 2. That was the coordinate of the midpoint of the line joining any 2 points. We can also apply this formula in vector. How? So this is your x-axis, this is your y-axis, this is your z-axis, this is your origin. There is a line joining 2 points A and B. Let's say that the position vector of this A be given by vector A. Position vector of the point B denoted by vector B. If R is the midpoint of the line joining the 2 points, then the position vector of this R denoted by vector R. Position vector of this pointer, vector R, is given by very simple.
Vector B.
Yeah, vector B plus vector A divided by no ratios M and N. Okay, just actually you are considering M and is to N to be 1 is to 1. Is it alright? Yeah. So you have to apply this formula in order to solve that. Question number 16, I think you can do that easily. So let me not do it, okay? The next one, question number 17.
Show that the points A, B and C with position vectors A, B, C, they form the vertices of a right triangle.
Right triangle, okay. So you have 3 points. You have 3 points. What are the there are 3 points whose position vectors are given, right? What are the 3 points here?
A, B, C.
Okay. Position vector of point A denoted by vector A.
Yes.
It's given to be
3 I cap
3i cap
minus 4 J cap
minus 4j cap
minus 4 K cap.
minus 4k cap. And then position vector of B, point B, denoted by vector B, no?
2 I cap
2i cap
minus J cap
minus j cap
plus K cap.
plus k cap. And position vector of C, vector C, will be given by
I cap
I cap
minus 3 J cap
minus 3j cap
minus 5 K cap.
minus 5. So you want to show that, okay, you want to show that they are the vertices of a right triangle, no? So if ABC is a right triangle, then this would be suppose, okay, it can be the other way. ABC can be anywhere here, okay? We are not sure, so we're just drawing a rough figure. In order to show that these 3 points represents the vertices of a right triangle, you need to prove that it satisfies Pythagoras theorem. Okay? Now, It should satisfy Pythagoras theorem. Only then you can conclude the other vertices of a right triangle. No? Yes. So Pythagoras theorem means square. Okay, how will you show that? How are you going to show that it satisfies Pythagoras theorem? You find out the measure of all the sides. Okay. If the sum of the squares of two sides is equal to the square of the third side, then the given points are the vertices of a right triangle. Okay. Position vector of A is given, then you need to find out vector AB. Position vector of all these points are given. See what I'm trying to say is, first you need to find out the measure of all the three sides though, right? You have to find the measure of all the three sides. Suppose this is your A, this is your B, this is your C. Let me just, or I can draw in any order, okay? We can draw it in any order. Suppose AB is directed like this, BC is directed like this, AC is directed like this. You can draw it anyway, no problem. Okay. Now, you need to find out the measure of all the sides. Only then, measure of all the sides means the three sides are AB, BC, and AC. Measure of this side means magnitude of AB. Measure of this side means magnitude of BC. Measure of this side means magnitude of AC. So in order to find out the magnitude, first you need to find out their vectors, right? Now, so how are you going to find out vector AB? How are you going to find out vector AB? Vector AB do kinaka pisaribo? How are you going to find out vector AB? Position vector of B minus position vector of A, right? So vector AB means position vector of B minus position vector of A. It is vector A. You got it? So let's find BC. BC means position vector of C minus position vector of B. And then you find out AC as well. Now, AC means position vector of C minus position vector of, alright? And then you find out their magnitudes. The magnitude of AB, magnitude of vector AB will give you the length of the side AB. Magnitude of vector BC gives you the length of this. Magnitude of AC gives you the length of this. Is it okay? Yes. So you find out their magnitudes and you know vector AB, so you can find its magnitude square root of x squared plus y squared plus z squared, right? Magnitude of BC and magnitude of, so magnitude of, okay, their magnitudes, magnitude of these three quantities gives you the measure of the sides. Now, if you can verify that sum of the smaller two sides in this example, sum of squares of the smaller two sides. Now, if the sum of the squares of the smaller two sides is equal to the square of the larger side, if we can show that, then the given points are the vertices of a right triangle. It's very simple. Is it okay? Yes. What else?
Right triangle, which of the following is not true?
Oh, not true. Which of the following is not true? Okay, you can see to it. It should satisfy triangular law of vector addition. Triangular law of vector addition means if two sides of a triangle are represented by two vectors taken in same order, then the third side is given by what? The third side of the triangle is given by what was triangular law of vector addition? If two sides of a triangle are represented by, oh, it's like this. if two vectors are represented by two adjacent sides of a triangle taken in same order, then the resultant is given by the third side of the triangle in opposite order. Opposite order. Is it okay? Yes. So it should satisfy the one which does not satisfy this condition is not the correct answer for number 18. Okay. So triangular law of vector addition says if two vectors are represented by two adjacent sides of a triangle taken in same order, then the resultant will be given by the third side of the triangle taken in opposite order. Okay.